Hello guys, welcome to Unified Science Lab. Today we are going to solve an example under electric power, and the question says, what is the power output of uranium reactor if it takes 30 days to use up 20 kilograms of fuel, given that energy release per fission is 200 mega electron volts, and they give the Avogadro's number to be 6.023 times 10 raised to power 23 per kilo. And now this is the solution. Let's go into the normal calculation. Then we will start by bringing out the values that is given in the question. First, we have to bring out the mass and other values that is given: the mass, energy released per fission, Avogadro's number, mass number of uranium, time, and others. So let's start with bringing out the mass that is given, which is the fuel used. Fuel used is equals to 2 kilogram. And another one, there is energy released per fission is 200 mega electron volts. Energy released per fission. Yes, we have the energy released per fission is 200 mega electron volts, and Avogadro's number is 6.023 times 10 raised to power 23 atoms per mole, and mass number of uranium is 235 kilo per mole, and the time given there is 30 days. 30 day time rather sorry time is equals to 30 days, and we have to convert everything to their lowest unit so that we can solve it very well. Let's start with converting the time. Time is one day is equals to 60 seconds times 60 minutes, which makes 1 hour, is equals to 60 seconds times 60 minutes is equals to 3,600 seconds. That's for 1 hour. Let me write again. This is equals to 1 hour. Then if this is equals to 1 hour, that means this times 24, which will make 1 day. So 1 day is equals to this 3,600 times 24, which will give us 86,400 seconds. Then we convert it to, let us convert it to a day, 30 days. If this is 1 day, then we multiply it times 30. This times 30 times 30, which will give us the time. Times 30 is equals to 2592123 seconds. That is 2,592 seconds. That's for 30 days. Time is equals to, this is the time, 2,592,000 seconds. Approximately, that's, you can even convert it also raised to power, but if you want to leave it that way, it's okay, there's no problem, but you can still convert it, but I would like to leave it that way. Then that's time. So the question here says we should find the power, the total energy, the power of the output. That's what the question says. find the power output. Power output is equals to unknown. So power output, this is the formula. Power output is equals to total energy released divided by time. So let's represent the total energy released as E. The total energy released as E and power output as P. So before we can get this total energy released, we have to multiply number of atoms times energy per the energy, the up one there, the energy released per fission. You have to multiply this times the number of atoms, which we need to find the mole first. We don't have mole here. We have the mass, we have the mass here, and we have also mass number of uranium. Yeah, but we need to find mole, and mole is given as moles is equals to mass over molar number. That is the molar number of uranium. So mole looks like I'm consuming enough space here. Let me write this small. Mole is equals to the mass is the mass given here. Let's do it to its small unit. Kilo is 1000. That's 2000 grams. So mass given here is 2000 grams over the molar number, which is the number of uranium, the molar number of uranium, and that's 235. The answer, if you divide very well doing the normal calculation, there we have 8.51 mole. And after that, finding the moles, you need to calculate for the number of atoms. So number of atoms will be number of atom. Let's represent it as N. Is equals to mole, the mole that you just calculate here, the moles times Avogadro's number. Avogadro's. Please, anyway you don't understand, you can ask a question in the comment section, or you can even pause the video, then try to get it step by step. That's the number of atoms represented as N is equals to 8.5. That's the moles times the Avogadro's constant, which is 6 times 0.23 times 10 raised to power 23. If you calculate this very well, for you not to have a wrong answer or made a mistake while calculating, you can put this in bracket before calculating. You can put this in bracket, then put this in bracket, so that you not made a mistake, so that it will not give you a wrong answer. So if you calculate it very well, this will be equals to this times this will give you the answer, which is 5.13 times 10 raised to power 24 atoms. You are looking for number of atoms, so you need to put the units very well. And now that we have gotten the value for the number of atoms, we need to calculate for the total energy released. And total energy released, while calculating this, number of atoms times energy released, this first energy released per fission, we need to calculate for that one also. So while doing that, we need to convert this 200 mega electron volts to joules. So while converting that, it means 1 mega electron volt is equals to 1.6 times 10 raised to power minus 13 joules. So if 1 is equals to this, that means 200 mega electron volts will be equals to 200 times 1.6 times 10 raised to power minus 13 joules. And if you do the calculation very well, the answer that will give you there will be is equals to 3.2 times 10 raised to power minus 11 joules. Please, you can pause the video, then do the calculation very well so that you not make any mistake. Follow the step. Anyway, you don't understand, pause the video, go back, watch it again. The steps from the beginning down here, because I'm about to enter another page now. Now you have gotten the electrons, the mega electron volts. You have converted it to joules. Now you want to solve for the total energy released, which will be the number of atoms times energy that we just convert here. That will be, I'm bringing in another page. So anyway, if you don't understand, you can go back to the main the other one and check it. So total energy released will be equals to, I represent this as E. I told you before. You can go back and check number of atoms times energy. This is not the total energy, mind you. This is the energy, the energy released here. The energy released per fission. That's the energy I'm talking about. This is not the total energy. So E is equals to the number of atoms that we had. There is 5.13 times 10 raised to power 24. If you don't understand, you can go back and check it. The value was there. Times 3.2 times 10 raised to power minus 11. This one is the 200 mega electron volts that we just converted to joules. So while multiplying it, to avoid making mistake or to avoid having a wrong answer, you may put this in bracket. By calculating it, put this in bracket so that it give you the correct answer. If you calculate that very well, you have your E. I don't want to bring in calculator so that it will not take much of your time. You can use that. Use this. Just put it in bracket. It will give you the correct answer. Because calculate it very well, give you 1.64 times 10 raised to power 14 joules. That is the total energy released. This is the total energy released. So we were asked to calculate the power. We were asked to calculate the power output. Power output of the reactor. Yeah, power output of the reactor. We were asked to calculate. So power output of the reactor is P. Alright, I wrote the formula before. It's equals to E over T. This is where the time comes in. So P is equals to, the E here is 1.64 times 10 raised to power 14 divided by the time. I did not approximate it. I leave it the way it was. So times 92000. Calculate it very well. You have P as 63. It looks like I approximate this one. 604.9. This one is too long. I can't leave the final answer like this. So I have to approximate it. 1, 2, 3, 4, 5, 6. Let me keep it here. 6. This point is not there. Don't make a mistake. Just keep it there. That will be 63. 63. I can't run it up, but I can run it off. So leave it that way. 63.10 raised to power 6 watts. Remember, it's power. The unit is watts. And I can also write as P is equals to 63. 10 raised to power 3 is megawatts. So this is the answer to the question that was given here under electric power. I hope you understand the solvings. And if you don't understand, you can ask a question on the part that you don't understand. I will take time and explain it very well to you. And if you miss something,